Welcome to Journal Club for December 9th, 2024. I'm Malcolm Diggs. A few years ago, many of the local businesses in my neighborhood started switching to cashless point-of-sale systems. This made a lot of sense for them. Keeping a ton of cash in the registers invited robberies and after-hours break-ins. It was a headache they didn't need, so cafes, restaurants, and even local groceries started ditching cash entirely. On its face, this was fine for me. No big deal. I'd just go from getting my morning coffee with cash to tapping my card or using a wallet on my phone. Easy, right? Well, no. For me personally, the transition was not easy. Not at all. Because my bank, who shall remain nameless, has what's got to be the worst fraud detection algorithm in the world. So I went through a period over a year where they would continually flag my card when I tried to use it. In the best case scenario, I'd be the guy at the front of the line in the coffee shop holding up the entire line while I called my bank to convince them that yes, it really is me buying this drink, just like it was yesterday and the day before and just like it will be tomorrow. Worst case scenario, they would instantly cancel my card and mail me a new one, and I'd spend the rest of the week waiting for my card to arrive and avoiding all the cashless shops until then. No matter how much I begged and pleaded with them to just turn the fraud detection off, they wouldn't. And this happened over and over and over. And then one day I realized something. They haven't frozen or canceled my card in a while. And it's been relatively smooth sailing ever since. Why did this happen? Why did it go from a system that flagged my shopping behavior constantly to one that seemed to work rather well? Did they change something? Did they upgrade something? Probably not. The difference I'm seeing is probably due to the fact that it's a learning algorithm. It's not a set of hard-coded rules, it's ML, and it has spent the last few years ingesting my buying behavior and determining what my normal pattern looks like. In the beginning, when I first started tapping my card, they didn't have any data for me. So they were probably comparing me to some base model archetype whose spending patterns look nothing like mine. But now, they know what I buy, when I buy it, and the model is customized to that behavior. But, wow. What a ride it took for me to get to this point. It just underscores the fact that fraud detection is way harder than it looks. It's hard to identify fraudulent behavior, and in my case, it's hard not to accidentally mislabel normal behavior. Why? Well, the primary issue is the imbalanced nature of fraud datasets that are used to train these models. Fraudulent transactions typically account for less than 1% of all transactions, and the skew complicates the learning process. Additionally, fraudsters frequently adjust their tactics, making static detection models less effective over time. Another issue is that traditional fraud detection models process data in fixed time intervals, limiting their ability to respond to real-time changes. Moreover, many conventional approaches fail to account for the contextual relationships between transaction elements, such as users, cards, devices, and bank accounts. Without these contextual insights, detection systems can easily overlook subtle fraud indicators. To help combat some of these issues, the researchers in today's paper introduce a new tool to add to the fraud detection arsenal. It's not a panacea by any means, but it is designed to be slightly better at certain things. It is a temporal graph network algorithm, a TGN algorithm, designed to detect fraudulent transactions by leveraging real-time event-based temporal graphs. A temporal graph network extends graph neural networks by incorporating the time, or temporal, dimension, allowing the model to track the timing of transactions and detect suspicious patterns as they unfold. Don't worry, I'm going to double back and define all of those things in a moment. For now, the important part is this. The proposed system models user interactions as a dynamic graph where nodes represent entities like users and devices, and edges represent interactions like transactions. By continuously updating the graph with new events, the model can identify emerging fraud patterns in real time. Okay, so let's go back. What are GNNs and TGNs? Graph neural networks, GNNs, are a class